Hello again everyone, this is Vardan from Stockholm, Sweden, and today I would like to talk about the process of analog to digital conversion, and this is part of the course week 3 assignment. So the analog to digital conversion process is basically that's the essential process in the modern music production, and it starts really with the transducing of the pressure variation of the sound into the voltage or audio signal in some device, and then it has to be converted into binary form. So the computer, in order the computer to be able to process this information. And speaking about binary information, it's the representation of information in forms of zeros and ones, and a single digit there is called bit, and the single bit can represent in this form either this 0 or 1, and a combination of bits is called a word length, and the word length can represent 2 to the power of its word length number of variations. I will show it in the next example. Here we have, let's say we have audio signal that varies from 0 to 1 volt. That's for simplicity, it's not a really realistic scenario. But we have a 2-bit word length, and but with only 2 bits we can really represent only 4 levels of this change in the voltage. You could see here. So from the lowest 0 to the 0.33, 0.66, and to the 1 volt, and it would be the combination of 00, 01, 10, 11. This is not really a realistic scenario in the real world, so usually the word length of 16 and 24 bit are used, so it's really allowing the really high accuracy representation in a digital domain, and the amount of combination you could have would be 2 to the power 16 or 2 to the power 24. Next, speaking about the sampling in general, it's the actual process of analog to digital conversion. And a sampling is a series of measurements that happens in the real time at the given sample rate. And the sampling frequency has to be high enough to capture all those variations in the incoming signal, so it would be really accurate. Here you could see some audio signal with the green, and then all these little measurements with the length of delta t, which is 1 divided by sampling frequency. So if we have sampling frequency of 44.1, then this is like measures 44 and 100,000 times per second. But also worth mentioning that's too low or too high sampling frequency might reduce actually the accuracy of AD conversion. If it's too low, then all the high frequency variation won't be visible. For example, here, if we would have a lot of high frequency variation within one period, we won't be able to see it in a digital domain later. And the too high frequency is really it's a limitation of hardware, so it will get a lot of noise. And the sampling rate might be a choice of particular instrument you want to record its frequency range, but the common sampling rates are 44.1 kilohertz or 48 kilohertz, and that's really what the human ear could hear, that frequency range from 20 to 20,000 hertz. And the quite common source of mistake while recording is really recording and playing at different sampling rates, because if you playing it back at a different sampling rate, totally change the pitch of the signal. And that's it for me today, and hope you enjoyed. Thank you.